All right, you have learned all about linear functions, equations, lines, and now we're going to move into looking at how we can model these. And so we want to look at determine equation of lines and then determine if we have two lines, if they're parallel or perpendicular, and then even be able to model data with a linear function. So if you recall the slope-intercept y equals mx plus b, or in function form, we know that the slope and the y-intercept of the line, if we know this, we can easily find an equation. So if you're given a line has a slope of -7/9, my brain goes, oh, this line is going down, negative slope, and it is hitting through the y-intercept at the point 0.16. I can quickly find an equation for this line because I know the slope and I know the y-intercept, and so I just simply plug this in either in the equation y equals format or the function format. And then as you can see here, if I'm given a point, I can do the same thing, that I know the value of y is 6, I know the value of x is -3, and if I'm given that the slope is -2/3 already in here, then I can actually solve this for the y-intercept and write this as well. Sometimes you're given maybe like 2 points, and we kind of like better the point slope because sometimes you have to find the slope first. So this is the point slope equation. So first, if I find the slope, my change in y is over my changes in x, and now I can plug in either point, which is kind of nice, and plug in the slope. And in this case now I can go through and I can solve this for y to put it in the mx plus b format. As I mentioned in the beginning, sometimes we want to know if we have parallel lines. If they notice here they're parallel if and only if they have the same slope but different y-intercepts. I can look at perpendicular lines where the product, if I multiply their slopes, I get -1, and also could be a vertical line perpendicular with a horizontal line. All of this that you're learning sometimes gets like wow, right? You're just like, I don't even understand what all of this stuff has to do with my life. And this is the cool stuff because you can actually use this to fit data. So let's say, for example, that I have this scatter plot and it says the cost of a 30-second Super Bowl commercial has increased 1.6 million. I wonder what it is now, right? And so we have this model here, and as you can tell by looking at it, it kind of looks like a line, right? Linear. And so we could choose any two data points and come up with a slope. And so if we come up with a slope, then we have these points that now we can plug into our point slope equation and come up with an actual equation. And why we do this, why we model, which if you ever take a statistics course, which is really nice, let me get all this to show up, is we actually come up with a model now that we could predict, and that's what they're doing here. We could estimate the cost of the commercial in the future. So all this stuff that you're learning in algebra definitely is very applicable once you get the basics down. And that's what you're learning first, is to get the basics down and then get to the point where you can start applying it.